Yeah, I think I mentioned a couple of compilers you can use. Um, the Zybooks actually in the Zybook exercises, they provide a compiler, so you can actually type a piece of code and then click run. So you're going to compile and then run. So if there's an error, you're going to show the error message. So Zybook provide a compiler for you, so you can use the Zybook compiler. But the disadvantage for Zybook compiler is that they only provide a compiler in the exercises. So if you actually try to do your own programming, and and then you have to actually scroll all these sections and find a compiler, so which is actually not very convenient. Um, so the other two compilers I mentioned last time, was one is the NetBean. Um, one is NetBean. Okay, so NetBean is compiler I have been used for many years. I think it was good. It was good. So NetBean is one of the compiler I just mentioned here. NetBean. The other compiler is the Eclipse. Okay, Eclipse. And these two compilers are offline compilers. So that means you you have to download the compiler. Before you do the downloading, you have to actually download the JDK, the Java development kit. So you have to set up something on your local computer, uh, for NetBeans and Eclipse. The good thing about these two compiler is you can actually pretty much work on your Java offline. So that means if there's a no actually internet connection, so you can just work on your local machine and do the compiling. Okay. Um, so you can actually try, if you want, you can try to download one of these and try to do it. Now, the other one I recommend, the other compiler I recommend is the repl.it. Okay, repl.it. So if you type repl, it's the replace all Java. Uh, that's basically the acronym for this. .it. So you can actually find this website, and so this is actually another online compiler, which actually works okay. I think which is good. You can, but you probably need to um, create your own account. So it's free. As far as for your personal use, it's free. So and the good thing is that this repl.it allows the team, a group, to actually work together on the Java code. I haven't tried this one yet, but I think you can actually try at least to work for your own. It works fine as far as your internet connection. You can just go to this website, and so um, you can create the pages for different languages. So Java is not in the list here, so you can click see all languages, and you can click Java. Okay, you can click Java and create a page. So for example, I have my replacement, my REPLs, and so I can create a couple of project. So one of this is my first one, my example. I click it, so it just provides that interface. The middle part, the middle pane is the place where you can put your source code, and the left one is actually basically it's kind of like a management column, so you can just list all your Java code, and the right side is the output. Okay, the consoles, and also the share. You can choose between console to share. So for example, like this code, I can just click run for this code. So I have an int x, I, and x. So I say I equals 5, x equals I plus plus, and then I print x and I. So if I click run, um, this is always the case that for most of the online compiler, it's always slow. And then you can see the output, x equals 5, semicolon, I equals 6, which is the, you know, printed out, the display, the actually message. Okay, you can try this. And I will talk about this a little bit more because I'm going to switch back and forth between the PowerPoint, Zybook, and if we try to, try some of the Java examples, I sometimes going to use this online compiler, which is actually very convenient. Okay. Okay, so let's actually continue with the topics. And for today, I think I'm going to stop my talking at about 10:25, and then I will ask you to log into another Google Meet links. I have created 3 links for and actually organized the 3 teams for the whole class. If you actually don't know about this, please check the Blackboard, check my first announcement, and I actually provide the names for each of the groups. I want you to actually, create a group, and then you can work together and, discuss any kind of issues, and then bring some of the questions, problems into the class. So I hope that down the road we're going to work that way. So instead of actually me, spend the whole class and talking, so I want you to be involved in that. So today going to be the first day. I want to schedule, create these links, and then you can actually start the conversation. And so maybe today you can spend a couple hours to do some kind of social, and so you can know each other, and then later on you can have some kind of discussion groups. So for each class, for this class, I created 3 groups, approximately 4 people for each group. So check the Blackboard. There's information over here. So I'll stop at the 10:25. Okay, so let's get it going. Okay, so I think chapter 2 basically going to talk about the Java data types. Okay, since that for most of the programming language, data types are pretty similar. So that's why I'm going to be very quick for each of the slide in chapter 2. So just keep that in mind. So I'm not going to spend much time in this chapter. So so last time we just mentioned that there are 2 different types of language. One is called a statically typed languages, and the other one is dynamically typed language. Java is statically typed languages. So that means if you try to define a variable, you have to declare the type of this variable. For example, if you declare a variable x as an integer, then you have to say int x semicolon, and then you can assign integer value to the x. Okay, so the x going to be a variable that stores the integer values. In Java, that basically means the Java actually going to reserve this x in the memory as an integer. Now there are some other language such as Python. They are called dynamically typed. So that means, so in Python, you can you can use the Python. You can, declare a variable x and assign a value to x. But you don't have to declare a type for the x. So like this one, the example I show here. Okay, so you can say x equals 2, which is a legitimate Python language. And you don't have to actually declare like an int x, something like this. Now, this is called a dynamically typed. So that means what is the type of x? I don't know until I assign a value to x. If I assign 2 to x, so x equals 2, so I assign value integer value 2 to x, then x is integer. And then later on, down the road, after I finish all this my computing, I want to reuse this variable, but this time I want to assign a double or floating point numbers to x. So then now the type of x has been changed because it was integer because I assigned an integer to x, but now it's a floating point. Okay. Now Java cannot do this. Once Java declare as integer, it is integer. There's no way you can change the type. Even you try to assign a floating point number to x. So you can do that, but Java gonna, eventually change the type of this value to x to integer, because even though you assigned a floating number to x, then that floating number going to be eventually converted to an integer, which is pretty bad, because if you actually try to convert a real number, a floating point number to an integer, you're going to actually lose some information because you're going to get rid of the numbers after the point. So that means the fractional part is going to be discarded, so which is pretty bad. So that's why for statically typed language, you must be very careful when you use it. Okay, so identify. I'm not going to spend much time on this because identify basically is a name created by a programming for items like a variables method. So anything you can just represent like a variable or method, that these are called identify. So typically for most of the language, Python or Java, the identifier is typically consists of a sequence of letters. Then you can use underscore in Java. You can use a dollar sign, and you can use digitals, numbers 0, 1, 2, 3. So you can use the combination of these characters. However, as an identifier, you can only start with letter, underscore, and dollar sign. Okay. So for example, so x1, that's a legitimate identifier. Y, yes. Oh, no, I'm sorry. I gotta say, that's not good word. So I'm gonna say say my name. That's a good identifier. Or you can say XYZ underscore 1. That's also a good identifier. Underscore X, that's a good identifier because underscore can. So, but the identifier have to start with letter, underscore, and dollar sign. Okay. You cannot say I want to name identifier like a 7 or 3 XT. That's not. Second, that's not, because you start with number, which is not right. Okay. Now, some of the word, like these are called reserved word. Please do not use the reserved word as an identifier. For example, in Java, int, int is actually reserved for integer. So when you declare x as an integer, you can say int x. Now you can say, can I use this as an identifier? So I say, oh, int. Okay, now we can. So because it's going to cause confusion. And also short is another reserved keyword. Double is another reserved keyword. So these are reserved word. Please do not use this as an identifier. Okay. Now, as far as you meet this criteria, that's a legitimate identifier. But in many actually corporations, many companies, they have some kind of a naming convention. Okay, there are two actually common conventions for naming variables. Okay, one type is called camel case. The other one is called underscore separated. So the camel case basically use the start, with the lowercase word, and then you can use the capital later. Sometimes because the idea to to name the identifier is to make the identifier meaningful, right? You try to make sure the identifier is descriptive to whatever you try to achieve. For example, in most of the example we actually did in the Zybooks, when you do the exercises, you're probably going to see some kind of identifier like num drink, okay? Drinks, okay. So what is this? So this is identifier, right? Now you can guess what does that mean? So normally, if you just try to say, I want to name a number of drinks as a variable. So maybe num drink is a good one. So now this is actually the camel case, So that means you try to actually say number of drinks, number of. Now you try to name a variable to represent a number of drinks, then you can use this. Okay. Or you can say number of drinks. That's another legitimate identifier, but that's probably too long, right? So you can, reasonably use this. Okay. That's a camel case. That means you can actually even put a small sentences in there, but so for every word, you can start with the capital letter. The beginning of the word, you use the capital, but except for the first word, so you can use lowercase. Okay, so that's camel. So lower camel case about about multiple words, and capitalize each word except the first. Like a number, num apples. That means people mostly mean number of apples. So all people on bus. So you try to count how many people on the bus. So you can use this as identifier. Now the other approach is use the it's called underscore separated. So instead of using the camel case, now I can use number of apples. Okay, num apple. Now instead of use capital A, I use an underscore, and then also use the lowercase or lowercase, or people on the bus. So now these are two different conventions, but just keep in mind, if you try in your programming, if you adopt one convention, then you just keep this convention. Okay, don't try to actually mix these two conventions. That's confusing. Okay, so in most of company, so they probably have their own rule. So they just say, okay, in all our software, please use the underscore separated. So you just use underscore separated. Okay. There's no such way to say which one is good or which one is bad. It's just a different way of, you know, representing and identify. So it's just different conventions. Okay. So here are the good practice when you actually try to do your program, because you can actually say, I want to use X to represent the number of drinks. I want to use Y to represent the number of students in a class. You can do that, but if that code is not read, that computer language is not program is not really readable, because when you write the program, you can use, say, oh, X represent number of students. But after a month or after a couple of months, when you come back and try to read your code, you probably forgot what X is. So you have to actually read it from the very start. So try to create a meaningful identifier is very, very good. It's a good practice. So create a meaningful identifier names that the self-described is an item purpose. Minimize use of abbreviations. Okay. So I can say number of FSU student. I can do that. Okay. That's fine. FSU is okay, right? Because we know that. But FSU probably is not abbreviation for people elsewhere. If someone actually in California, they just read the code. They have no idea what is FSU. Okay. They're probably going to interpret as a Florida State University or, Framingham State University. Anyway, so that's just, you must be very careful. Try to use the abbreviation very smartly. For example, like a NASA. Well, everybody knows what NASA is, right? But some of the abbreviation going to cause confusion. And also find a balance between abbreviations and a long variable name. So like in this case, number of drinks, you can use num drink. Now this is not a very confusing, and it's reasonable size. Number of drink, yeah, that's fine, but this is long, right? So that's the trade-off. So try to actually practice. Now, if you stick with any of these convention, just stick with it. Don't change it. It's just a different one. Now, do not use these word as the identifier. These are reserved word or keywords in Java. So abstract, final, finally, float, for, go to, and any of these are reserved word. They carry meanings in Java. Okay, so just keep that in mind. So for some of these, you know very well, like for int, double, where's double? Yeah. Now later on, when we talk about a branch, then you can say if, else. These are reserved word in a control structure. Okay. Now arithmetic expressions. Again, I'm not going to spend much time on this because this is exactly the same as Java. Okay, so you use that means addition, subtraction, multiplication, division. That's basically carries the same meaning for Java as for the Python. It's basically the same. So when you try to write a math arithmetical expression, it's pretty similar. Okay, except when you write the statement, at the end of the statement, you have to put a semicolon for Java. But for Python, you don't have to do that. Okay. Now also the parentheses, unary, minus, that means it's a negative, right? So if you say 3, okay, then you say -3, that's -3. Okay, so that's basically saying. Now I hope you can remember these these are the when you actually do the evaluation for math expression, there's a precedence rules. Okay, the precedence rules are pretty much the same between Java and and the Python. So if you have actually parentheses, everything inside the parentheses is going to be evaluated first. Okay, and then the unary, the -3. Okay, and then the multiplication, division, and that's called a modular operation. I can explain this a little bit later. Modular operation is basically, it's a division, but when you divide it, so for example, x modular y, that means x divided by y, and the result is the remainder. Okay, it's a remainder. Okay. So these actually operation going to be the next, it has a priority after parentheses and the unary, and then the plus and the minus, and then left to right. If you're talking about the same the operations in the same at the same presence level, then it's always start from left to the right. Okay. So now here are some examples. If you say 2 times parenthesis x plus 1, then even though multiplication has the higher precedence than the addition, because addition is inside the parentheses, so you're going to evaluate x plus 1 first. Okay, even though this has a higher precedence than the multiplication, but you're still going to evaluate the plus first because x plus 1 is inside the parentheses, because parentheses has highest priority. Okay, now 2 times minus x. So in that case, you're going to evaluate minus x first. Okay, and then multiply this with 2 by 2. Okay. Okay. So then in this case, 3 plus 2 times x, because multiplication has a high priority than plus, so you can just evaluate this first and then evaluate the plus next. So you can actually, and that, it's basically the same rule than Python, and also, it's exactly the rules that just like a math expressions. Okay. Now, next one we're going to talk about is data type. Okay. So I'm going to very quickly on this, because later on we're going to actually try to do a little more practices. Okay. So data type in Java, there are many data types, just like a Python. You have an integer type, you have floating point type, and the most widely used floating point type is double. Okay. And then there's another type is called a float. Float and double basically means the same type, but double actually going to reserve actually more computer space. So double can represent a bigger number or even smaller number. Okay. So a floating point is a real number, okay, which contains the point. Okay. So for example, 98.6, 0.001, or 55.667. So now remember that we talked about a scanner, right? Use a scanner, so we can declare a scanner. So I can say scanner equals new scanner system dot in, right? And then you can say scanner. So you can use the scanner dot next int to import the next value from the prompt. So you can assign the value into X. So this way you can import a integer value. But now for the double, for the floating point number, you can use next double. If we next double, it allows you to type the floating point number and assign to X. Now just make sure that when you actually use next int, make sure x is an int type. Okay. Oh, I'm sorry. Int x. Sorry. I hope you can read this, but it's int space x semicolon. Okay. But if you use the double, then you can actually say scanner dot next double, and you can assign a double. Then you have to declare y as double, right? So next int, import the integer value. Next double, import floating point value. Now, one of the things that you can use is the scientific notation. Now, you remember that the scientific notation are basically used to represent a huge number. For example, 6.02 times 10 to the 23. That's a huge number. If you write this number in just regular number, then it's going to be like a 16.20000 dot 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 0. How many zeros you can actually put? 23 positions. So that's a huge number. So that's why you're going to write this number as 6.2 times 10 to the 23, right? Now that's called a scientific notation. Now scientific notation is good for most of the floating point number, particularly extremely big number or extremely small number. So when you say I want to represent number, say 0.000000000000123. Now if I want to represent that number, how can you do this? And you can just say 1.23 times 10 to the what? So now you can check how many actually positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 10 to the minus 14, right? Okay. So that's the scientific notation. Allows you to represent an extremely huge number or extremely small number. Okay. Now in Java, you can use this 6.2 times 10 to the 23. You can use 6.02 E23. E basically represent the power of 10 exponent. Okay. So this is the same as this. Use E. Now what about this? How can you represent this number? Right? You can represent this number. So that's the power. Okay. Any questions? So I think I know I'm very quick, because I want to actually quickly go over these slides. And so if you want to actually the detailed information, you can just check the Zybook, and also Zybook provide the follow-up exercises after each of the topics. So like this number, 0.001, and you can put as 1 times 10 to the minus 3, and you can write as 1.0 e minus 3. Okay. So that's the scientific notation. Using Java, you can use this notation. Now the other type is the constant variables. Okay. Now, for example, if I ask you to calculate the area of a circle, okay. So let's say the radius of the circle is 4. 0.0. Now, if the radius of the circle so that's the radius. So what is the area? Can you tell me, anyone?
Is that a 4 for the radius?
4?
No, for the radius. What is the is it 4.0 for the radius? Okay, I
Yeah,
see it.
yeah,
So
4.0.
would it be 8.0?
I say area 8.0. I mean the area of this circle.
Oh, I see.
Yeah, it's a pi. It's supposed to be pi times. Okay, pi times r square. That's correct. So if the radius, they're going to be radius square, right? So now here, using the um, Java, I can put something like a pi, but the value for the pi is 3.4. Okay, so I just multiply the radius twice. That's a radius square. The other way you can do is use the math formula. That's something we're going to talk about later. So that's the area, right? Now, this is actually not really convenient. So that's why sometimes we're going to actually say, well, I don't want to do this. I want to actually say, define this as a pi, which is and I can use this as a constant variable. So I declare as a constant variable. What I going to do? So then I can use final. Okay, double pi equals this. So then I'm going to declare a variable pi as a variable, but it's a constant variable because I use the final keyword. So then the area going to be pi times radius times radius. Okay. Because every time in place of the pi, I can just simply type pi instead of this long number. Okay. So that's you can declare as a constant variable. So the constant variable is to declare as it's a variable, right? It's identified, but you cannot change the value because when you declare it, you put a final at the beginning. So that's called a constant variable. Constant variables are very useful when you try to in the program, you don't want other people to change this variable because you declare as a constant variable. So for example, uh, the rate, for someone's like a salary rate or the um, G, you know, the grade for each of the course, then the grade you're going to say, um, A, B, C. You can declare A as 4.0, but you instead of write 4.0, you can just define as an A. But in this case, you're going to say final integer A equals 4. Final integer B equals 3, right? So you can define with English character, English actually character A, B, C to define different score. Okay, so the next thing we can talk about is the math methods. Okay, so we have learned a math And there are many formulas that we have been used. And in Java, we can use these math methods, okay, without even define these, without defining these methods. Okay, now, so here are some of the methods used in Java. These are the three methods we can use. And SQRT, that means the square root of x. Okay, now, so square root of 9.0, that's 3.0. But if you try to use Java to calculate this, you're going to say math dot SQRT 9.0, okay, equals x. And then this is going to actually calculate the square root of 9.0 and assign the result to x. So x will get 3.0. Okay. Now, the next actual method is a POW. So it's not a prisoner of war. It's a power, actually. It's a power. Basically, it just represents x to the y. So when you actually say POW, x and y, then, you know, when you actually use this, you can say math dot POW 6.0 colon a comma and 2.0. So that means it's a 6 square. So you eventually get the 36 because that represent 6 to the 2. Okay. Now that's absolute value. Okay. So absolute value of 9 minus 99.5 is 99.5. So what is this? What is the math ABS 10? What is going to give you?
Would it be 10?
Yeah. For a positive number, the absolute value is also a positive number. It's the same number. Okay. So then you can use the other. There are many actually available functions, math functions you can use in Java. Like most of the functions, like logarithms, all the trigonometry functions, like a sine function, cosine, tan. So these functions, you can always use without defining it. So, but when you use it, make sure you just put a math, capital M, math dot the function name, and then the argument, the parameters. Okay. So we will get there when we actually do more problems. Okay. Now, one thing I want to mention is the division. Particularly when you apply the division to integers, you're probably not get what you want. Okay, so let me ask you, what's the division if I've divided 3 by 2?
You're gonna get a decimal.
Yeah, 1.5. That's math, right? Now in Java, if you say if x is an integer type, what is the value of x?
1.5.
X will be 1.5. Now if I declare x as an integer, actually x will get x will be surprise, right? Now this is actually how Java, not just Java, maybe other language, most of the other language you're going to do. So when Java actually look at this expression, Java look at the first number 3, it's an integer, and then the division, right? And then second number is also integer. So in that case, Java are going to treat, because it's an integer. So both actually, numbers are integers. So it's 3 divided by 2, which is 1.5, which is not an integer. However, Java are going to actually treat that kind of operation that way, because each of the operand are integer, is integer. So Java are going to assume that the result also going to be integer. So in that case, if you got 1.5, Java are going to actually convert the 1.5 to an integer. How Java going to convert the real number to integer? It just get rid of the fractional part, get rid of the number after the period, after the point. So that means 3 divided by 2, you will get 1.5, and it will convert to 1. Oh, I'm sorry, it's 1. I'm saying 1, but I just wrote 2. Okay. Now, how to avoid this kind of situation? I really want to actually get the correct answer, not 1. No, 1 is not correct, right? So, so in that case, we sometimes call this division floor division. So that means when you actually divide the numbers, you got the result, and you get rid of the fractional part, and you just put down to the floor. You assume that each integer is a floor, and somewhere, this is 0, this is 1, this is 2, and this is actually in the middle. It's a point. It's a 0.5. That's a 1.5, right, in the middle. So the floor basically means you only have this. If it's 1.5, you're gonna drop down to the floor, which is 1. If it's a 0.5, you're going to drop down to 0. So now how can you say, if I really want to actually do the 3 divided by 2, but I want to actually get the result 1.5, what do you do? There are a couple of ways you can do. One, you can say, instead of writing 3, you're writing 3.0 divided by 2.0. Now you're going to say, wow, that's nothing. What's the difference between 3 and a 3.0? Yes, in math, 3 and a 3.0 are the same number. But Java is stupid because it's a computer language. Because when Java C3 and Java C3.0, Java going to store these two numbers in a different ways. When 3.0, Java going to say, oh, this is a floating point number, and this is also a floating point number. So the result going to be 1.5. It's a floating point number, so that should be fine. Okay. Now you can actually assign this number to y if I declare y as a double. Okay. So y will be 1.5 instead of 1, because in that case, Java going to treat all the numbers as an integer, so the result should be integer. So you're gonna get rid, even though the result is not an integer, it will just force to convert to integer. There are a lot of actually tricks in there, so you need to actually do more practice. Now, another actually example is like, let me actually show you. What do you think? What the result going to be if I? Okay, let me erase this. Okay, so if I declare x as an integer, and then I'm going to say x equals 3.0 divided by 2.0. So what is the value of x?
1.5.
1.5.
The value would be 1 because it's an int.
Okay. Yeah, the answer is this. Why? 3.0 divided by 2.0, this will give you 1.5, which is fine. That's the floating point. But now you assign the floating point number to an integer. So this way, because x is an integer, so if this is actually floating point type, this is an integer type, then the Java gonna force the number convert to integer. So x will be 1. Remember, if I declare x as an integer, you cannot change the type of it, x. X always gonna be integer, no matter what. Even if you assign a floating point number to x, the Java gonna force the conversion and force that number to be an integer. So this is so on. Now what about this? Double. Why? And I'll always give you a tricky one. So y equals 3 divided by 2. Now y is double, remember.
Pretty
Well,
sure it's still 1 because the two values are 3 and 2, not 3.0 and 2.0.
okay, so 3 divided by 2 going to be 1.5, but it will force to be 1, right?
Pretty sure.
So, yeah, then 1 assigned to y, but y is double. So it's actually, yeah, you're close, but still not correct. Y is 1.0. Okay, it's not a 1. Because, so here, your result is 1. But you try to assign an integer to a double number. So the integer will be converted into a double number. Then they're gonna put the 1.0. So just doing a little more practice, you will get there. And here's a modular operation. That's the division, but it will actually keep the remainder. So 24 divided by 10, you got the quotient 9 and the remainder 4. So the answer is 4. So this is a 4. Answer is 4. 50 divided by 50, modulo 50, it's 0 because 50 divided by 50 is 1 with remainder 0. 1 modulo 2 is 1 because 1 divided by 2 is 0 with remainder 1. So this gives you the remainder, okay, when you do the division. Okay. Okay. Now the type of conversion. That's something I want you to look at, you know. It's a little confusion because it's gonna deal with, you know, because just keep that in mind. You know, Java is stupid. It just do whatever people tell it to do, you know. So if you actually, so there's always, you know, if you have a type mismatch, for example, if you have an assignment x equals 2.5, and then because you assign 2.5 to x, but if you 2.5 is a floating point number, but if you declare x as an integer, so you assign a floating point number to an integer, and then there's a type mismatch. If there's type mismatch, you have to actually do the type of conversion. Okay. Now I want you to actually read this 2.12 and to see how these type are going to convert to each other. Okay. Now these kind of conversion is called implicit conversion. Implicit conversion, because you know x equals 2.5, and the right side is floating point, and if x is declared as an integer, then when you do the assignment, you can actually convert implicitly. You know, that's the danger of it, because sometimes people just don't realize this, and still think x is 2.5, which is not, because x is integer type. How can an integer type x store a floating point number? You can't. That's a reality. Computer is not a human being, because if you tell computer you have to store integer for this type, and the computer gonna actually force everything into that type. Okay, that's called implicit conversion. Okay, now same thing with the other case. If you declare x as a double, and then you assign 2 to x. Now this case is a little bit better than the other case, because when you actually assign integer to x, then you don't lose anything, because x is going to be 2.0, so still the same number. But the other way is very dangerous, because you assign a floating point number to an integer, you're going to actually drop the fractional part. Okay. So one thing, implicit conversion is, sometimes people just try to do this intentionally, but just keep that in mind. This is dangerous, because even though you want to do the implicit conversion, but other people read this, they may actually misinterpret things. So one of the best way to do this is use type casting. So you just make it explicit. So for example, if you say x is an integer, and then y is double. So when you say x equals y, so you basically assign whatever stored in y into x, because x is double, y is double, y could be 2.0, 2.5, right? Assigned to x, you're going to drop to 2.0, or actually drop to 2. So now if you actually really want to bring people's attention, then you can do this. X equals int y. So that's a casting. So y is a double, then you just force the y to be an integer and then assign to an integer type. So this way, it's basically, these two are basically perform the same thing. There's no difference between these two. But this one, people will not be confused. Okay, that's called type casting. So again, you need to do more practice to work on this. There's a lot of trick in there. Okay. So I'm not going to actually continue with the other one, but I want you to actually spend more times on the spend some times and read the characters. Okay, how to import the character. Character is just like ABC. So character. So X. If I define a character, it's a lowercase. So I can assign X equals A. So that's a character A. Okay. So character, and it's a very similar to the other actually type called a string. We're going to talk about a string is like hello. That's a string, right? Hello world. That's another string. And there's actually in a string, if even there's space, and the space is going to be treated as a string. Okay. Now each individual character, so you can, sometimes people just view character as just one character string, but that's slightly different, because for the string you use double quote. For character you use single quote. Okay. So that's the differences. Okay. Now string is widely used in both Python and the Java. So so I think I'm not going to go over these, from 2.14 to 2.15. I'm not going to spend much time on this, but one thing I want to mention is the difference is a string variable is called a reference type variable. So that's something I'm going to talk about later on Monday. So just keep that in mind. I'm going to talk about this on Monday. So what's the difference between variable, a reference type, and the other type is called like an integer and the floating point. These are called primitive type. Now, string is a variable type. Okay, reference type. Okay, reference type basically means you're gonna actually point to an object. It's an object. It's not really a space that to store a particular one. I'm gonna explain this a little bit later. Okay, so I think I'm gonna stop right now, and please do your assignments. And even if I haven't covered, you can actually continue to do it, read the topics, and then immediately do the practice. And when I actually talk in the class, you can actually ask a question, because if you actually do ahead of time. So I hope you do this. And for the remaining time, I want to, want you to actually log into a different links. Now these links are actually in the Blackboard. So let me actually show the Blackboard. Let me just hold on. Okay, let me see. Okay. Okay, so I organized the 3 groups into group 1. Samuel, Jonathan, and Shaki and Kyria, you are in group 1. So you can use the first link. And the second link, it's Matthew and Spencer, Alex, and Abigail. And group 3 is only contains 3 people.
Professor, should I join group 3 if I'm new?
Oh, you're new. Okay.
Yes.
You can join 3. Okay.
All right.
Just send me the. Yes. Okay. Yeah. Yeah, just join the 3 right now. So you can actually have some kind of chat, introduced to each other, and then once you know each other, and every time when I say it's a group time, then you can just log into your group. And basically, I want you to actually discuss it, and hopefully, down the road, that before our next lecture, maybe you can put together. I may actually give you assignment to say, please discuss this chapter sections and present three questions. So
Do you mean 3 questions in total or from each person?
total. Yeah, total. So what I'm gonna do is I want you to actually assign a team leader for each group. Now you can switch the team leadership, because for this week, probably say, Samuel, you're the team leader for group 1 this week, and the next group discussion, and the next one gonna pick up the team leadership. So I want you actually to do this. But today I'm not gonna give you any assignments. I just give you, time to know each other. So let me just just introduce to yourself and get to know each other. So that's the purpose. So during your meeting, I may actually jump in any of these group. Okay, so okay. Okay, so I'm Okay, are you there yet?
Oh, we could go to our groups now?
Yeah, you can go to the group right now. You can. So today we don't have much time left, just about 10 minutes. So you can just chat to each other, get to know each other, and maybe you can select a team leader and for the first week, for the first actually for the next meeting.
Okay, thank you.
Okay. Yeah. I think that's pretty much all for today. So thank you.